Welcome to Homework Lib.
What we're going to do is find the most stable conformation for the following molecule. That is the one that appears here in the corner. And the first thing that we need to do is to label the carbon atoms. So this is going to be 1, 2, 3, 4, 5, and 6. Next up, we need to remember that whenever we start writing down positions, we're going to use the same numbers that we did on the first one. So I'm going to start with a 1 over here. 1, 2, 3, 4, 5, and carbon 6. And on the other side, we need to keep the same order, but we flip the chart. So that means that now carbon 1 is this one on the corner, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So recall that this is going to be a chair flip. For now, I'm going to omit the equilibrium lines because we just want to draw the most stable conformation. So on this conformation, we're going to have an equatorial and axial position. So over here, in the axial position, we're going to have a nitrogen atom in carbon 1, and then here on the equatorial one, we're going to have this little fella going down. So this is in the equatorial looking down position. Next up, we're going to have on carbon 2, in the axial position, we're going to have an hydrogen atom. This is axial going down, and we're going to have a CH3 looking at the equatorial up position. So this is our CH3. This is equatorial looking up. Finally, on carbon number 4, we're going to look at the position looking up. In this case, we're going to have the following compound corresponding to also equatorial looking up position. And looking in the actual down position, we're going to have a nitrogen atom that we can omit by now. So this is going to have all of the substituents in the equatorial positions. So this is a hint that this is going to be the most stable configuration. Now let's verify what happens when we put it on the flip chart conformation. On carbon 1, looking down, over here, we're going to have our group corresponding to an axial looking down position. Is axial looking down. On carbon 2, we're going to have as well looking up, in this case, a CH3 that is going to be in the axial looking up position. And finally, on carbon 4, looking up corresponds as well, in this methyl group, an axial up position in the chart conformation. So the one that is going to be the most stable is the one with the most substituents in equatorial position. In our case, it would be this conformation over here. And just for completion, if you want, we can clean up the hydrogen atoms to make this guy look a little bit better, since we can always omit it. I just wrote them down for reference to look what are the actual positions on each of them. So with this, it would be all. Thank you very much and have a good one.